Good morning, third period. Let's get some new notes. Today's going to be a little bit tricky. Remember, you can always call me. We have a Zoom Monday, Wednesday, and Friday from 11 to 12 if you need extra help. Our goal today is we are going to be applying negative exponents. This is section 8.3 in the book. We're also going to be applying the exponent of 0. So when you have negative exponents, here's our problem. It starts out as 2 to the negative 1, but we can think of that as 1 times 2 to the negative 1 because 1 times anything is just itself. If you see, I've got this 2 to the negative 1 in a cloud. Negative exponents are unhappy. It's kind of like you teenagers. You're not happy where you're at. Right now, you don't want to be at home. You don't want to do homework. We want to make you positive and happy. So this negative 2 does not want to be in the numerator. It doesn't want to be up top. It wants to be down in the basement with all its cool friends. So whenever you have a negative exponent, think of it as being unhappy. It doesn't want to be where it's at. So we're going to take this 2 to the negative 1. It doesn't want to be in the... It wants to be in the denominator, so we're going to move it downstairs. So when we do that, it's going to make it happy. So this 2 to the negative 1 is going to be written as over 1, because we can make anything as fraction by multiplying it by 1. We're going to move it downstairs. It now becomes a positive 1 when it's in the denominator. It's happy. It's where it wants to be. We need a placeholder to put where it was at, so a 1 is going to go there. So we've got to have something that stays up top. So let's look back at our notes here. Negative exponents are unhappy. It doesn't want to be where it's at. Sometimes they'll be in the denominator, sometimes they'll start in the numerator. 2 to the negative 1 doesn't want to be, or it wants to be in the denominator, wants to be downstairs. So we move it down. Now the exponent is positive. It's happy. Okay, then we need a placeholder in the numerator, which is where our 1 comes from. So let's go back and look again. 2 to the negative 1, the negative 2 it's not a negative 2, it's just unhappy where it's at. We got to move it where it's at to the other, down to the basement. It's now happy. We have to have a placeholder for where it was so that the 1 goes there. Let's do another one. Example number 2. 2x the quantity to the negative third. So we can think of that as 2x to the negative third all over 1. I made it a dotted 1 because we had to put it over 1. Dividing by 1 is not going to change it. This is unhappy being in the numerator. So we're going to move it to the denominator to make it happy. Now we have a positive 3 as an exponent. We need to hold its position by putting a 1 where there was nothing at. So now we have 1 over 2x cubed, and we need to simplify that. 2x cubed means 1 over 2x times 2x times 2x. 2 times 2 is 4 times 2 is 8. So we have an 8 in the denominator. X times x times x is x cubed. We have an x cubed in the denominator. So our final answer is 1 divided by 8x cubed. Next problem is going to deal with negative exponents. It's also going to deal with that value of 0 for an exponent. We have 3 times 3 to the negative 1. So there's 2 different ways that you can do this. Make these fractions by putting them over 1. 3 divided by 1 is still 3. Negative 3, or 3 to the negative 1 is still, it's a positive 3. The exponent is negative. That means it's unhappy. So we can rewrite this as 3 over 1 times 1 over 3. We multiply our fractions straight across. We end up with 3 times 1, which is 3. 1 times 3, which is 3. 3 divided by 3 gives me Mr. 1. Okay, or we could have added our exponents. I'm hoping that you saw that in the section 8.1 as the more we did, is that you can add the exponents together. We have a 3 to the 1 times 3 to the negative 1. If we add those exponents together, 1 plus a negative 1, we get 3 to the 0. Anything to the 0 power is equal to Mr. 1. Okay? So next problem. We have 2x to the negative 2, y to the 3. The only things that are unhappy are the x's and the y's. Only x's and y's have negative exponents. That's all that wants to be moved. The 2 wants to stay right where it's at. It likes being there. The x's want to go to the denominator. The y's want to go to the denominator. So 2 stays put. The x's become positive when they're moved to where they want to be. The y's become positive when they're moved where they want to be. So we end up with 2 divided by x squared y cubed. Okay, let's go through some more examples. Example number 5. Example number 5 says 3x to the negative 2 divided by 4. And again, you see I've put a bubble around the x to the negative 2. The 3 wants to stay where it's at. The 4 is happy where it's at. The only thing that's not happy is the x to the negative 2. So only the x's have a negative exponent, so only the x's move to the denominator. So we end up with the 3 staying on top, the 4 staying on the bottom, and now the x squared goes to the bottom denominator with the 4. So we end up with 3 divided by 4x squared. Next example, example 6. We have 1 divided by 3x to the negative 4. If you look, I've put a bubble around the x to the negative 4. And it's not just variables that can be negative, have negative exponents. Numbers can too, but so far the ones we've done have just been variables. The x's are the only thing that have a negative exponent. Only x's have a negative exponent, so only x's move. So looking back at our problem, the 1's going to stay in the numerator, the 3 is going to stay in the denominator, the x's want to move up to the numerator, so it becomes x to the 4th over 3, or you could have left that 1 there that was already there, because it's just going to be 1 times x to the 4th. It's not going to change anything. Okay, example 7. 2xy to the negative 5th, the whole thing cubed. The only thing that's unhappy are the y's, so we're going to take care of that first. So we have 2x over y to the 5th. Now we're going to cube it. So we have 2x times 2x times 2x over y to the 5th times y to the 5th times y to the 5th. So community property says I can rearrange it. 2 times 2 is 4 times 2 is 8. X times x times x is x cubed, so I have 8x cubed. On the bottom I have y to the 5th 3 times, which if I count up all my y's gives me y to the 15th. Final answer is 8x cubed over y to the 15th. 2 more problems. Next problem. Example 8, 3 to the negative 2 times 3 squared. We can think of this 2 ways. We can, because our bases are the same, we can add our exponents. Negative 2 plus 2 gives me 3 to the 0. Anything to the 0 gives me 1. Or we can take this 3 to the negative 2, make it a fraction by putting it over 1. We know that that 3 does not want to be in the numerator, so we're going to move it down to the denominator. Leave a 1 as the space holder. The second 3 was happy where it was at. We're going to put it as a fraction over 1. So we end up with 1 over 3 squared times 3 squared over 1. When you multiply fractions, you multiply straight across. We end up with 3 squared divided by 3 squared, which 9 divided by 9 gives me again Mr. 1. Anything to the 0 power is going to give me 1. Okay, last problem. 4 to the negative 2 squared. We're going to make that a fraction by putting it over 1. This 4 to the negative 2 does not want to be part of the numerator. It wants to be downstairs in the basement, so we put a placeholder of 1 on top. When we move it down, it becomes positive. So now we have 1 over 4 squared squared. 4 squared means 4 times 4, and we're squaring that, so we're going to write another 4 times 4. So we end up with 1 over 4 to the 4th if they're asking for your answer in exponential form. Okay, if they'd ask you for the value of it, you would take 1 and give me the answer of 4 times 4, which is 16. 4 times 4 is 16, whatever 16 times 16 would be. You got to look at the directions. What is it asking for? All the problems I'm giving you are odd. I want you to try them all. Check them in the back of the book. Call me when you have questions. Page 506, 3 through 19, the column. That means straight down. Then 29, 31, and 33. Okay, if you have questions, give me a call. Talk soon. Bye.